Hello and welcome to today's lesson. We're still in our first area volume unit. We're looking at lesson 2. And in this lesson, we are going to look at and investigate the formulas for the area of a triangle, a trapezoid, and a kite. So we're going to look at, build these formulas, understand how the formulas work, and use those formulas to solve problems. So now, when we look at the area formula for a triangle, if you think back to our last lesson, we looked at rectangles and parallelograms, and we saw how a parallelogram is built based off of the rectangle. And there is no difference when we come to a triangle. A triangle area formula is also based off of a rectangle. So if you notice in this lower shape, I took our original triangle, which is based on a base and a height measurement, and I've added some pieces to it. And if you notice, these pieces are exact matches to the two parts of this triangle. So you can see we have an exact match here, and all I'm doing with these pieces now is I'm taking these pieces, pulling them out, and tacking them on to the triangle itself. And what shape have I made? I've made a rectangle, and we know what the area formula for a rectangle is. The area formula for a rectangle is base times height. But now, when we're looking at the red part of this shape, or this rectangle, okay, the red portion is only 1/2 of that. And that is how the area formula for a triangle is built. Okay, the area formula is 1/2 base times height. You're going to be given that on your formula sheet. You know, it is a good area formula to memorize. Okay, but you'll always have it to find. But you want to understand, why does it work? It works because if we can build a rectangle, we understand how the pieces of the rectangle work with any area formula to help us find a triangle, to help us find the parallelogram in our last lesson, and it's also going to help us find the area formula for a trapezoid and a kite. So now, when we're working with any triangle, what we have to remember is we have to remember that the base and the height are perpendicular. They have to make a 90-degree angle. So even though it is outside of this triangle, okay, our base measurement is the 5, and the height measurement is a perpendicular distance from whatever we pick for the base to the vertex of the opposite side. So the 7 centimeters here becomes our height. So if we're going to find our area here, okay, we have 1/2 times our base measurement of 5 times our height measurement of 7. So we have 1/2 of 35. Okay, and 1/2 of 35 is 17.5, I believe, right? But this is early in the morning, so I'm going to double check that. So we've got 35 divided by 2, or 35 times 0.5. And then we're always looking at our units, centimeters squared. Because remember, when we're finding an area, we're finding how many two-dimensional little centimeter squares can fit in and build this shape. Okay, now, in certain situations, we could use the 8 as the base, but what we would need, once again, is we would need the perpendicular height to the opposite vertex. So since we don't know this measurement, we could find it now. Okay, we could use our area formula, plug in what we know to find that x value, but since we're not given that height, okay, we wouldn't want to use that. Now, understand, looking at our next picture, this allows us to see and know that the bottom measurement is not always the base. What we have to understand is the base and the height have to be perpendicular to each other. So in this second image, I can either make 3 the base, which makes 4 the height, or I can make 4 the base, which makes 3 the height. We can do that either way. And then we just plug into our area formula. So that's the good part about area volume units, is we have the formula. We just have to be able to find the right pieces and plug in and solve and understand what this solution means to us. So we have 1/2 of 4 is 2. 2 times 3 gives us the area of 6. You can really kind of multiply these pieces in any order as you're working through, as long as you're comfortable with how those work together. Okay, and I should always include my units of centimeters squared. Okay, now trying to find the length of the base. So now we're trying to find this distance B, and remember, whenever they take one measurement away, they have to give us another measurement. Okay, so we have 3 variables here, and we need 2 of the 3 to be able to solve the problem. So since we don't know what B is, they give us the area of 40, 1/2 B times our height measurement. And remember, base and heights have to be perpendicular. So you're looking for that perpendicular measurement. Our height value then is 8. Now, there's a number of ways you can solve this problem from here. You can undo one piece at a time. We can undo the 1/2 by multiplying both sides by 2. That would get rid of the 1/2. Or we could do 1/2 of 8, and we have 40 equals 4b, and then we divide both sides by 4. And we get B equals 10. Once again, looking at our measurements, since it's a base, it's not a square unit, it is just 10 centimeters. Okay, now for our next shape, the trapezoid. Okay, give you the area formula right here. Remember, the area formulas are always on your formula sheet. You can use them for any test, midterm, or final. So you have your area formulas there for you to use. But what we want to understand is, why does this formula work? Okay, once again, we're always trying to build into a parallelogram or a rectangle. So notice what we did here. Okay, we have our 2 triangles, or 2 trapezoids, excuse me, and we've made a direct copy of the first and just turned it upside down. So now if you notice, our base measurement is the sum of the top base and the bottom base put together. Okay, our height measurement is the same height for both. But when we think about it, we're always looking about how much, what percentage is the original trapezoid. And just like with the triangle, the original trapezoid is 1/2 of the shape that we have created. Okay, and that's going to be a very common number here. So we're always trying to make rectangles, make parallelograms, and use that formula to help us get the answer for the trapezoid, for the triangle, and then when we look at the kite, we will see that as well. So this is why the formula for a trapezoid works. Okay, what we're doing, turning it into a parallelogram, adding the 2 bases together to give us a long base. The height stays the same, and since we have 2 of the shapes, we have to cut it in half to get our final measurement. So now, using the formula, okay, always be careful of slant heights. Our true height is always a perpendicular distance, and we've got our base 1 and our base 2, so sometimes it's always good to label your values. So then you can plug the pieces into the formula. Base 1 of 5 plus base 2 of 11 times our height of 7. Okay, and then from here it always just becomes a simplifying piece. 1/2 of 5 plus 11, which is 16, times 7. And you can always multiply these in any order. That's the good part about multiplication. One thing I look for is I always look for, can I do a 1/2 of an even number? Because 1/2 of 16 is 8. And then we just finish up by doing 8 times 7 equals 56. Okay, now, you are always allowed a calculator, so if you just want to plug it in to the calculator and run straight through, 0.5 times 16 times 7 to get your answer, you can always do that. But if there's anything that we can do mental math-wise to make our work a little bit easier, those are things that we want to look for. Now, what else can we do? It's always the missing piece type of problem. So here when we have a missing piece, we've got a missing height. They replace the height because we need something else with the area. So we start with our area formula, plug in what we know. Area equals 1/2 base 1 plus base 2 times h. We know the area is 96, so we can plug that in and we can start simplifying. 8 plus 16 is 24, so we have 1/2 of 24 times h. 1/2 of 24 is 12. Okay, so we're always trying to get to our simplest form here, and then we finish up by doing the opposite operation to get h by itself. The opposite of multiplication is division, and we have h equals 96 divided by 12. Okay, I believe it is 8, but let's do this here real quick. Okay, and we've got a height of 8 centimeters. Okay, once again, in Schoology, you don't have to type the centimeters in. That measurement should be there for you. Okay, we're looking for the value when we solve. Now, our last formula for today, finding the area of a kite. Okay, a kite is denoted by a quadrilateral, four-sided shape where the consecutive sides are congruent. And what we do with the kite, like we do with any other shape, to build our formula, notice there's some new measurements in our formula. D1 is diagonal 1, so we're looking at our diagonal distances. D2 is our second diagonal. But once again, we want to see, why does this formula work? Okay, and if we copy the pieces of the kite, once again, we can put the kite together and turn it into a rectangle. How would we find the area of this rectangle? Diagonal 2 all the way across. So you want to be careful. It's not 2 diagonal 2's here. Let me use a different color since we're working on red. Okay, but it is diagonal 2 is this distance. Diagonal 1 is this distance, and we can see that that would be the base and the height of this rectangle. Now, do we need all of this rectangle for the kite? No. Like all of our other shapes today, we're using that 1/2 multiplier because our red kite is only 1/2 of this rectangle. So now, let's work with a couple kites here, just so we can find the area one time, and then 2, given an area, when they take a diagonal away, how can we find that missing measurement? So now, in this situation, the area of a kite, 1/2 diagonal 1 times diagonal 2. So area equals 1/2 of, now, diagonal 1, based on this diagram, is we're actually given 2 measurements. So we have to put those measurements together to get a measurement of 6 for diagonal 1. And then for diagonal 2, we've got 10 plus 4, which is 14. Okay, so now, as we go through, we want to solve. Once again, you can always type it into your calculator, but let's do some quick mental math. And what I'm actually going to do here is I'm going to apply the 1/2 to the 14. I want to take that 2-digit number and turn it into a smaller value, and I get 7. And then we have 7 times 6 equals 42 centimeters squared for our area. Okay, so once again, when you're applying the values, doing the multiplication, you can do it in any order you want. If you want to just do it on the calculator, definitely go that route. It's an easy way to get those values for you. So now, finishing up here, we're given the area. We're taking away one of our diagonals. So we have to go through and use the formula, plug in what we're given, make sure that there is only one missing variable, because that's all we can solve for right now, is one missing variable. So we have 140 equals 1/2 of diagonal 1, 7 plus 7, which is 14, times diagonal 2, which is the AC length that we're looking for. Okay, now, notice there's a lot of different things that we can do here in order to solve this problem. If you're most comfortable with simplifying the right-hand side, I'm going to show that method, and then I'm also going to show another method, and it's just trying to look at and find some things that make the problem a little bit easier to solve. So here we've got 140 equals 1/2 of 14, 7 times AC. And then we just have to divide both sides by 7, and we get 20 equals AC. Now, the other option we had is if we have 140 equals 1/2 14 times AC, I could divide by 14 and get 10 equals 1/2 of AC. Well, if 1/2 of AC equals 10, then we know that AC equals 20. Okay, so once again, two different ways to look at the problem. You want to pick what's most comfortable for you, but I always want to show a few different options when they exist. Okay, that concludes our lesson for today, looking at the areas of triangles, trapezoids, and kites. And remember, it's always about getting the base times height and then finding that 1/2 conversion factor. Thank you, and have a good day.